We're just gonna go over the L'Hopital's rule problems, because that's the one you need to know for the AP exam. Which is coming up 5 weeks.
What is the date for that?
May 4th, so 5 weeks from tomorrow is AP exam already. We don't have that much time to prepare. But look, Jaime Escalante did it in 1 day.
Yeah.
So we can do it in 5 weeks, right?
Yeah.
Oh wait, to be on the video, we gotta be here. 1A. Okay, limit x approaches 0. In fact, anyway, this is the first thing we're gonna start reviewing is limits. X sine x all over 1 minus cosine. So the first thing you always do when you compute a limit is plug in the number. If you plug in the number and get 0 over 0, what does that mean? It's indeterminate. So what you have to do is you have to do other things, like you can simplify, look for friend, multiply by conjugate, but the easiest thing to do is use L'Hopital's rule. So L'Hopital's rule says you can take the derivative of the top, and since it's a product, you're gonna use the product rule. So derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. And the derivative of the bottom will be 0 minus, and the derivative of cosine is negative sine x. So basically, if you take away the 0, what happens when you plug in 0 for x now? You still get 0 over 0. So that means you can use L'Hopital's rule again. So the derivative of this is just cosine. Over here, you gotta use the product rule again. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. Some of you are getting your derivatives and antiderivatives mixed up, you know. And that's gonna pose problems on the multiple choice because they know exactly the kinds of errors students make. And the derivative of sine is cosine. Now, can you plug in 0 and get something? And the answer is yes. You will get 1 plus 1 plus 0 over 1, which is 2. Now, some of you are applying L'Hopital's rule when you cannot. Now, you only can do it when it's 0 over 0 or infinity over infinity. And remember, on the AP exam, if you do this, if you go 0 over 0, right there, a point is taken off. Because 0 over 0 is undefined. There's no such thing as 0 over 0. So do not write 0 over 0 on your paper. And I already told you how the AP exam wants us to do it. In fact, I'll show you on this problem. Limit. Maybe I'll show you on a different problem that's easier. Okay, so if you plug in the number, you get 1 minus 1, which is 0 over 0. So you can use L'Hopital's rule. So take the derivative of the top, the derivative of 1 is 0, and the derivative of negative secant x would be negative secant x tangent x. And the derivative of x squared is 2x. But if you plug in 0, you still get 0 over 0. So we're going to use L'Hopital's rule again. So negative, and then you're going to use the product rule on that. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. All over the derivative of 2x is 2. Now can you plug in 0 and get something? And the answer is yes. If you plug in 0, you're going to get negative 0 plus 1 over 2, so negative half is the answer. So that means you have to know how to compute derivatives. Okay, C. These are all derivatives that come up on the AP exam. This was probably the hardest of the 4 problems. So if you plug in 0, you get 0 over 0. So L'Hopital's rule. 1 minus, the derivative of that is 1 over root 1 minus x squared. The derivative of that is 3x squared. Now what happens when you plug in 0 again? It's still 0 over 0. So you do L'Hopital's rule again. The derivative of 1 is 0. Now this is the same thing as 1 minus x squared to the negative half power. So if you put the negative half in the front, it's going to become plus 1 half box to the negative 3 halves times the derivative of box. derivative of the bottom is 6x. Now, some people were doing the product rule again, but that's crazy. Why not just cancel out the x's? Because if you can cancel, right? And then this 1/2 cancels the 2. Now, can I plug in 0 for x and get something? Yeah, you get 1 times -1 over 6. -1/6 is your answer. And then the last problem, some of us are still confused with the fundamental theorem of calculus part 1. Limit x approaches 3, integral 6 to 2x sine 5t, over x squared minus 9. So what happens when you plug in 3 for x? You plug in 3 here, 2 times 3 is 6. What is the integral from 6 to 6? 0, and 9 minus 9 is 0, so this is 0 over 0. So you use L'Hopital's rule. Now, how do you take the derivative of an integral? That's the fundamental theorem of calculus part 1. You make sure the lower limit is a constant, which it is, and then you take the 2x and you plug it in for the t there. What do you get? If I take 2x and plug it in for t, what do you get? Sine of 10x over, and then what's the derivative of this? 2x. Now, what happens when you plug in 3? You get sine 30 over 6. That's the answer. Now, some of you are doing L'Hopital's rule again, but you cannot because it's not 0 over 0. Question?
Don't you have to multiply by the derivative of 2x?
Oh yeah, I forgot that. See, I'm the one who forgot. You gotta plug that in, and then I forgot the most important part. You gotta multiply by the derivative of that, which is 2. Then of course, then the answer is the 2's cancel out, so it's actually only 3 on the bottom. Thank you for bringing that up. That's the most important part of the fundamental theorem of calculus, part 1. You gotta multiply by the derivative of that. And then everything else, okay, that's just bonus question.
For C, when you do 1 minus x squared to the negative half.
Take the derivative of this.
Yeah, what happened to the negative?
Oh, because this is a minus, right? So when you put a negative half in the front, it cancels out, right? That negative will cancel that negative there. Okay, so L'Hopital's rule. It's gonna come up quite a bit. Alright, so let's take a look at the assignment sheet. So, we're gonna spend 2 nights reviewing the entire course. Like I said, if Jaime Escalante can do it in 1 day, we can do it in 2 days.
Oh, we're doing it in 2 days?
Yeah, we're Iolani. And then there's 7 types of free response questions, and we're gonna cover them one at a time. So we start, the easiest one is this, area and volume, and we got all these other ones. And then there's gonna be a buffer, so like, you're gonna learn it, we're gonna learn something else. 2 days after we not learn it, but review it, then you're gonna have a quiz on it. Okay? And then starting from the 6th, there's a quiz every single day. And that's how, some days you're gonna have 2 quizzes, in fact. Cause sometimes we have to have like speed quizzes and, well, don't you have to know all your derivatives and integrals? And then of course, I haven't really filled in everything yet, but the AP exam, right there, May 4th. So, like I told you, did you guys read your comments?
No.
Yeah.
Yes.
Anyway, it mentions the day before we have a study session. Now normally, if we're in school, we'll have it like in this room after school, like we usually go from like 3 o'clock to 6 o'clock. Okay, but you know, I don't know, maybe it might be better to just do it at home, 7 o'clock to 10 o'clock.
No.
Why not?
The online stuff.
Yeah.
Yeah, can we do it here?
Okay, well we cannot have potluck like we normally do.
Why not?
Cannot.
What if we bring our own individual food?
Cortez.
But you can't share it though.
What if we
Okay.
You're one of the give us a round.
No, we're not gonna go outdoors. We're gonna do it in here anyway. Anyway, that's gonna be the study, and like I said, from the course evaluations, that's like one of the most important things on gaining confidence to get a 5 on this exam. And then, so basically, to get your quarter grade, it's gonna be all your quizzes and the final exam.
There's a final exam.
Yeah, right there.
It's just a cumulative test.
Yeah, but we're gonna know everything, right?
In
But here, come on,
That's like a
if you're like
final
1, 2, 3 days before the test, we should know everything, right? I would hope so. Alright, so make sure you know what the correct assignment is, like tonight's homework is AB review problems 1 through 10. And then on Wednesday, AB review 11 through 18. So where am I gonna get all this material? Well, you go to your folder right here on the bottom, review for AP exam. Click on that. Okay, now there's already a whole bunch here. Okay, let me show you the important stuff. The first thing is the cheat sheet. You see this right here? AB notes or the cheat sheet. Everything you need to know on the AP exam is on this sheet. There's everything. Got some pre-calculus stuff, rules for horizontal asymptotes, distance formula. Okay, right here. This is where the calculus starts here. Definition of the derivatives. This is what we're gonna have to cover. And then I give you examples too. I mean, this is just like the cheat sheet for SAT prep that I spent half my career making. Anyway, everything is here. All the theorems, intermediate value theorem, extreme value theorem, mean value theorem. Remember those?
No.
No, no. Everything is here. So how many pages? Slope fields, properties of integrals. Okay, this is important. Justification. There are certain ways that you have to justify your answer. We've been doing it all along, but now you're gonna have to be responsible for it. So everything's in there. In fact, there's a 20-point justification quiz just on this alone. You're gonna have to like justify your answer. Like, is this function continuous? Yes, but then you gotta say why. But don't worry, we're gonna go over it. And everything on here, then look, got your list of derivatives and integrals. Trig identities. Now I noticed in the past 10 years, there's a reduced emphasis on trigonometric identities. And remember now, you don't have to simplify any answers on the free response now. In fact, I don't want you, starting from today, do not simplify your answers. If you get 2 plus 3, then just leave it 2 plus 3. Do not simplify it to 5. Because if you simplify it wrong, 2 plus 3, and you write 6, a whole point gets taken off. That could be the difference between a 4 and a 5. Anyway, that's the cheat sheet. Anytime you, I forget the formula, go to the cheat sheet. I forgot how to justify this, go to the cheat sheet. Okay, here is tonight's homework. You see right here, AB review. This is the homework for the next 2 nights. AB review. So, problems 1 through 10. And then on Wednesday it's going to be 11 through 18. And then I give you all the answers right there. So you can see if there's a lot of words written. That's because you have to justify your answer. Mr. Park, the answers are not enough. Well, right here, solutions for AB review. Let me change that. I'm going to rename it. Let's call it AB review solutions. That way they'll be next to each other. There. AB review and AB review solutions. So I don't know when I did this. I think Christmas vacation I did this. So every single problem is all worked out. But don't just look at this and copy it down now. You only look at this if you need help. And then starting on, when are we going to start doing, shoots. What am I doing? Look over there. Look over here. starting on Thursday, then you're gonna start getting actual AP exam problems. So, the first one is area and volume. That's one of the easier ones. So, the first homework, you look it up and then go, okay, FRQs, free response questions, area, volume. This is the homework. Google. So these are actual AP exam problems. This is the year they were in. So I'm just giving you 4 for each assignment. No, I'm not gonna make written solutions for this. But what I am giving you is, so if you wanna look up the solution, what you gotta do is, you go to here, AB, FRQ, and the scoring guidelines. So click on that. Now I forget that first one, what year was it from? 2013, so you go to 2013 scoring guidelines. All the problems are taken from 2010 to 2016. So you click on that. Now this is what you guys gotta remember now. If it's problem number 1 or number 2, that means you get to use your graphing calculator. Problems 3, 4, 5, and 6, no calculator. Every single test is the same way. So since this is a number 2, that means you can use your calculator. That's why they have decimal answers over here. See, now notice what you have to do to gain points. So the problem, every single free response question is 9 points. So in this one, you have 3 parts. Now you might think it's 3, 3, 3, but no. In this one, it's actually 4, 3, and 2. So to get 4 out of 4 points for this, what you have to do, it says integrand, that means this. So this is obviously, what is this? When you do a volume, pi, big R squared minus small r squared. What is that again? It's a washer. So if you get the correct integrand, that's this thing in the brackets, you get 2 points. They want to see big R squared minus small r squared. Limits, if you have the correct limits, 0 to 2.3, you get another point. And then the final one is your answer. Normally what happens is you write the integral and then you get the answer. That's what you need to write on your paper. Integral and answer. So usually the integral part is worth 2 points and the answer is 1 point. But every year it's different. They have a committee that decides what the points are. So then if you have, I'm giving you all of this information now. So if you have a question like, I still don't understand how they got it, then make sure you bring it up in class the following day. And then of course, all of these assignments are going to go, there's a show me folder now called 4th quarter assignments. Just put everything in there. Now, I can give you points for homework, but what I normally do is we just set up a minimum score and then nobody will score below that. What do you want it to be this year? 60.
No.
60% of what?
Last year they wanted 80, that's why.
Of what?
Like overall grade.
No matter how bad you do on the quiz, because the quizzes, they're gonna be tough, you know. So what I normally do is whoever gets the lowest one, just curve it up to an 80. So nobody gets a bad grade.
Sure.
85.
But that's only if you do all the homework.
Oh, that's, yeah.
Every homework not done is gonna be a minus 10% off that
Oh my
curve.
god, we gotta grind.
95 and then minus 10.
100.
Yeah, but what if you don't do 3 homework? Then that's 65.
Well, you could just simply do all the homework.
95. Anything below that gets curved to 95.
I'll think about it.
Yeah.
So you have to know what's in this folder now. I mean, I can make written solutions, but it's gonna take me pretty long to do it. But if you want me to, I will.
Yeah.
I didn't do it last year. Actually, I did. Now that I think back, I did. But we got a whole new set of problems this year, so I can do it. I'll think about it. All right, so let's start the AB review. Okay, so you need to do problems 1 through 10 tonight, so we start with limits. Now, you guys just don't know how good L'Hopital's rule is. Because problems like 1A, 1B, so easy to do with L'Hopital's rule. You don't even have to remember, what is a limit?
Where it approaches.
Yeah, so like, if this is 3, if the limit is 6, that means coming from the left and coming from the right, no matter what the graph looks like,
6.
it's going toward the same point. And what is the y-coordinate of that point? 6. That's what a limit is. A limit exists if the left-hand limit and the right-hand limit are the same. What would happen, like over here, here's 5. What would happen if the left-hand limit and the right-hand limit are different? Then the limit does not exist. So the only way for a limit to exist is it's got to approach the same point from the left and the right. Because sometimes they actually give you a picture, you know. Sometimes they don't just give it to you like this. But like I told you, now we have L'Hopital's rule. So for those of you who don't like to factor and do stuff like that, you can just do L'Hopital's rule, like this. Okay, if I plug in 3, you get 0 over 0. Now remember, this is, if you're on a multiple choice, they don't care if you show your work or not. All that matters is the answer. But if you are on the free response, the way they want you to handle L'Hopital's rule is they want you to do the numerator and denominator separately. So they want you to do this. You take the limit of the numerator, which is 0, and then you take the limit of the denominator, which is also 0. Do not write 0 over 0 on your paper. That's a -1 right there. Okay, so if the top and the bottom both go to 0, you can use L'Hopital's rule. So what you do is you take the limit of the derivative of this, which is 2x, which is 6, and then you take the limit of the derivative of the denominator, which is 1, and then you go, I guess you could say something like, by L'Hopital's rule, the limit is 6 over 1, and you can just leave your answer like that. Do not, I'm going to warn you, do not simplify that to 6. Just leave it 6 over 1. Anything with arithmetic in it, no need. In fact, even trig values you don't even have to know. If you come up with like cosine pi over 6, you can leave the answer like that. You don't even have to simplify that to root 3 over 2. Anything like cube root of 8, just leave it. You don't have to simplify that to 2. Question?
Do you get points taken off if you spell his name wrong?
No. They don't take out for spelling.
But you have to write it though?
What I would like you to write it, so that they want you to refer to definitions and theorems, right? This theorem is L'Hopital's rule.
So then you box that whole thing.
No need box it. Just you don't have. You just write this on your paper. That's good enough.
Wait, why can't you just say like that goes to 0 instead of like doing the top and bottom of it?
Or you mean like, oh, this goes to 0, and then this goes to 0.
Yeah.
But then there, 0 over 0. It's on your paper.
So then do you need
Oh no,
to
I'm not making this up. Okay, this is what they want. Just do it.
Okay.
Just do it. Believe me, I have issues with AP. I have many issues with that. So we just do what they say. We get our fine and we go along our merry way. That's what's going to happen. Okay, what about something like this now? Limit x approaches infinity. 3x squared plus 4x plus 5 all over 4x squared plus 5x plus 6. Now I would like you guys to get this answer without using L'Hopital's rule. Yeah, remember if the degree of the bottom and the bottom are the top and the bottom are the same, then you look at the coefficients, 3/4, because that's the horizontal asymptote, right? If the horizontal asymptote is y equal 3/4, then the limit as x approaches infinity means, as the graph is going out to the right, it's getting closer and closer to 3/4. Question?
Would we get points taken off if we just did like that, like not having to use the L'Hopital's rule?
This would come up on the multiple choice. This is too easy for her free response. Yeah, so that comes up several times. And then of course the most important one is the definition of the derivative.
What's that?
Well, they've got several in there. So here is the definition of the derivative. F prime of x is equal to the limit as h approaches 0.
Oh, that thing.
F of x plus h minus f of x all over h. This is all in the cheat sheet. you might see something like this. What is the limit as h approaches 0? In fact, as soon as you see h approaches 0, you know already, this is the definition of the derivative. Okay, so how about cosecant x plus h minus cosecant x all over h? And they'll give you 4 choices. Well, this is the derivative, but then you gotta figure out, well, what am I gonna take the derivative of? This is the function right here. See, this is the function. So this is computing the derivative of cosecant x, which we know is, or we don't know, negative cosecant x cotangent x. And that's why we need speed quizzes every now and then. If you don't know your derivatives, they're going to try and trick you left and right on the multiple choice. Like, you know but have this answer and going to have the same answer without the minus sign. So you got to get your minus signs straight. Okay, the other two
Wait, sorry, can you just say what you did again?
take the derivative of this. This is what you got to look at.
Oh, yeah.
See, because here's f of x, right? F prime of x means the derivative of f. So whatever function is right there, that's what you're taking the derivative of.
So wait, what would the problem say again? Like,
Compute this limit.
Oh, okay.
Okay, now the two other definitions of the derivative are this, f prime of a. So that means at a particular point, limit h approaches 0, f of a plus h minus f of a all over h. That's pretty much the same thing as this one, except you got an a instead of an x. But the other one you gotta know is this one, limit x approaches a, f of x minus f of a all over x minus a.
Oh, we gotta know how.
You gotta know all of them. Okay, and it can show up anywhere now. So here could be an example. What is the limit as h approaches 0, cosine of pi over 2 plus h minus cosine of pi over 2 all over h? So you can tell that it's this one right here, right?
Yeah.
What do you do? Or it's just like this one, like right here, you look at this. So you look at this, except instead of pi over 2, think of this as an x. Okay? So what if there were an x there? What would the answer be?
Sine.
What is the derivative of cosine x?
Negative sine.
Negative sine x. But the problem is they don't have an x there. They have a pi over 2 there. So that just means you're going to plug in pi over 2 into the derivative. See, f prime of pi over 2. So you take the derivative and then you plug in pi over 2. So what would happen if I plug in pi over 2 into the derivative? Now you got to actually know your trig values because this is going to be a multiple choice question. Negative 1 is the answer. Okay, now normally how would they test you on that one? Well, usually what I've seen is they give you a graph like this.
Wow.
Okay, let me think. Okay, they might give you a graph like this. See, this is f of x, and they'll ask you something like, what is the limit as h approaches 0? F of 0 plus h. No, you know what? Let's make that a 1 then. F of 1 plus h minus f of 1 all over h. Well, according to this, look at this right here. What is this equal to?
Derivative of
F prime of 1. That means what is the derivative or the slope when x is 1? So here's 1 right here. What is the slope
0.
when x is 1 right there?
D.
Sharp, it's a sharp point. The limit does not exist. Anytime the graph comes to a sharp point, there is no slope. There is no derivative. The derivative does not exist. And if you'd ask you why, if this were a free response question, why doesn't the limit exist there? Remember I told you what to say?
Oh, I forgot.
There's a sharp point there.
Wait, is that actually what
cause there's certain things they will accept, we're gonna go with sharp point. Okay, what about this? What is the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h? Well, what is that equal to then?
What is it, 2?
F prime of 0, right? Whatever number is here, you're computing the slope at that point. So here's 0, right there. What is the slope of the graph right at that point?
1.
No.
2.
It's 2. Because the slope is rise over run, 2 over 1, 2. Slope is like one of the most important concepts in calculus. Derivative means slope. Okay, we gotta do one more. What is the limit as h approaches 0, f of 2 plus h minus f of 2 all over h?
F prime of 2 is
Okay,
0.
that means f prime of 2, which means what is the slope when x equals 2? So here's 2 right here. What is the slope right there?
0.
It's horizontal, the answer is 0. I know what you're thinking, Mr. Park, how am I gonna remember all this stuff? How am I gonna know everything on the cheat sheet? Well, the second half of class, after we go over the homework and stuff like that, you know what we do? We do drills, just like Javi Escalante. Stand against the wall like a snake, and then everybody answers a question. Remember I told you that? No. Except you're not gonna stand against the wall like a snake. Just sit in your chair like a sloth, and I will answer questions. We just do that every day, and by the time we get to the exam, you guys know everything. It seems to work. Okay, next thing on the list. Okay, you guys remember the product and quotient rule? We don't have to review that, right? Just remember, you start with low now when you do the quotient rule. So like number 2, you have to do the quotient rule. Low d high minus high d low, all over denominator squared we go. Okay, absolute value. Okay, let me do a problem like number 4. F of x is equal to, how about we go 3x minus 1 all over absolute value of x minus 1. So, what does it say to do? Compute the limit. Okay, so how do you handle something when you see an absolute value? What do you do?
Positive.
You make a piecewise function. That's what absolute value is. Just remember, here, this is the definition which is on the cheat sheet. If the inside is positive, you leave it alone. If the inside is negative, you negate it. That's how absolute value works. So, you look at that. If the inside is positive, you leave it alone. That means you get this. 3x minus 1 over x minus 1. If the inside is negative, you negate it. See, so absolute value of x, it's either equal to x or negative x. In this case, it's going to be negative x, so you get this. Okay, so now let me ask you this. How do you compute the limit as x approaches infinity? Which of these do I look at? Not both. No, x approaches infinity.
Top.
What, as the graph is going out to the right, does that mean
Top.
x is greater than 0 or less than 0? Okay, so you look at that one. What's the limit as x approaches infinity? 3. We just talked about this. If the degree of the top and the bottom are the same, you look at the coefficients. That's the horizontal asymptote. In fact, if they ask you what's the limit as x approaches infinity, that means what is the horizontal asymptote? What's happening as the graph is going out to the right? What's the limit of this function as x approaches negative infinity? That means as the graph is going out to the left.
Negative 2.
Then we look at this. What is the horizontal asymptote for this one? It's negative 3, because if the degree of the top and the bottom are the same, you look at the coefficients. 3 over negative 1 is negative 3. What would happen if the degree of the bottom is bigger? Like what if that was an x squared there?
0.
Then the limit would be 0, because that's the horizontal asymptote. If the degree of the bottom is bigger top, then it's 0. Okay, other questions they can ask. What is f prime of 1? What does that mean? You take the derivative and you plug in 1, but Mr. Park, which one do I plug it into? Well, 1 is greater than 0, so take the derivative of this, which is a quotient, so you gotta use the quotient rule, so you go f prime of x, so how does quotient rule work? Low d high minus high d low, all over denominator squared we go, and I shouldn't put a 1 there because that would make it undefined.
3.
So just plug in 2. You guys can plug, and remember, when you plug in 2 on the free response, all you have to do is this, 3 times 2 minus 1 times 1 all over 2 minus 1 squared. That's full credit on the AP exam. They just want to see you're plugging it into the right thing. Okay. Okay, linearization. Do you guys even remember what that is?
No.
Linearization.
Making a line.
Yeah, that's right, making a line. The tangent line.
Oh, I remember.
Okay, here. Let me give you a function. Ooh, let's say y equals square root of x. Here is the point 4, comma 2. Write the equal. That's an ugly picture. I don't like it. I'm gonna do it again. Now I'm gonna tell you on the AP exam, they do not use the word linearization. They're just gonna say, write the equation of the tangent line when x equals 4. Okay, so what are the two things you need to write an equation of a line? You need a point. Well, we got a point, but then now you need the slope. And what tells you the slope of the tangent line?
Derivative.
The derivative. Okay, how do you take the derivative of this? Have we memorized that one yet? I can't tell.
1 over 2 is x.
Okay, so good. If you know this, good. But if you don't, then you gotta go, okay, that's x to the half. So the derivative is 1/2 x to the negative half, which is that. But then again, if you're gonna memorize it, make sure you memorize it correctly now. So at this particular point, what is the slope?
1.
What happens when I plug in the x coordinate into the derivative?
1, 4.
You get 1/4. Okay, so now that you got the slope and a point slope, y minus 2 equal 1/4 times x minus 4. Ding! You got 2 points on the free response just for doing that. And then they're gonna say, use your result to approximate f of 4.3 or something. Something that's close to 4. Okay, so what is f of 4.3? That would be the y coordinate on the graph when x is 4.3. But can you see that the point on the line and the point on the actual curve is almost the same? The error is very tiny. So we can estimate it by, instead of plugging it into the original function, because how many of you know what the square root of 4.3 is off the top of your head?
No, 2.
Yeah, so what we do is we plug in 4.3 into the line equation. So all you have to do, remember what we do? Move the 2 on this side. So you get 2 plus 1/4 x minus 4. And all they want you to do is show that you're plugging in 4.3 into your line equation. So your answer would look something like this. Y of 4.3 would be 2 plus 1/4 times 4.3 minus 4. And if this is free response, you just leave it. Do not simplify that. Just leave it. They just want to see you're plugging it into the correct thing. Another question they could ask is this answer an over or an underestimate?
Over.
Well, you can tell from the picture, but then what if they give you a function where you don't know what the...
Plug it in.
Concavity.
Concavity, yeah.
Okay, you gotta look at the concavity of the graph. So, if the graph is concave down, then the line is above the curve. The point on the line is above the actual point. Then you have an overestimate. But if the graph is concave up, then the point on the line is below the point on the curve, and then you get an underestimate. So how do you write what do you need to write down to get the points?
Second derivative.
You gotta second derivative tells you the concavity. So if this is the first derivative, what would the second derivative be? Negative 1/4 x to the negative, you gotta make the power 1 smaller. Okay, and if you wanna simplify it to this, negative 1/4 x root x. No, you don't wanna do that. You don't have to, okay? Now, what you gotta do is you gotta figure out what the concavity is at that point. So you gotta plug in 4 into the second derivative. So what is y double prime of 4? And you just have to show them if it comes out positive or negative. You don't need the exact number. If I plug it in, you get negative 1/4 times 4 to the negative 3/2 power. Is that number positive or negative? It's a 50-50 chance. Come on, a negative times a positive is a negative. It's negative. Which means y is concave, which way? Down. Now you cannot abbreviate now, I'm just doing it. The only way you can abbreviate on the AP exam is you gotta make a legend. I just do it just to save time, okay? So that means we have this situation, like this, it's concave down. See, that's what I mean, don't just memorize, draw the picture. If it's concave down, the point on the line is above the point on the curve, so this is an overestimate. That's what they want to see. You figured out the concavity, you said it was negative, so therefore it's concave down, therefore you have an overestimate. Okay, next. Okay, continuous and differentiable. Ooh. You guys probably forgot, huh? Okay, let me give you a piecewise function. Guaranteed this is going to be somewhere on the test. X squared when x is greater than or equal to, no, less than or equal to 3. And then, 5x minus 6 when x is greater than 3. Is this function continuous at x equal 3? It's a yes or no question. Continuous?
Yes.
Plug in 3. Yes.
Yeah, if you plug in 3 here and 3 there, then you get the same number. Yeah, 9 and 9. So that means they actually meet, which means it's going to be continuous. So yes. Okay, 1 point. But then they're going to ask you why. Remember what you have to do?
Limit.
You got to refer to the definition. Yes, because, and do you guys remember the definition? The limit of this function as x approaches 3 is equal to f of 3. That is in the cheat sheet under justification. That's the definition of a function being continuous. And they're both equal to what? 9.
Do we have to write that?
Yeah, you should. Okay, now, is this function differentiable? What does differentiable mean again? The function is not just continuous,
Smooth.
it's smooth as well. In other words, no sharp point. Differentiable means literally it has a derivative. It has a slope. That means you cannot have a sharp point. Okay, so that means in order for a function to be smooth, the left-hand slope and the right-hand slope gotta equal. So what you gotta do is you gotta look at the left-hand slope and the right-hand slope. So, here's your piecewise function. What is the derivative of that? 2x. What is the derivative of that? 5. So when x is equal to 3, is the left-hand slope and the right-hand slope equal? Like if I plug in 3 for x, will that equal that? No. 6 is not equal to 5. That means there's a sharp point there. So the answer is no. It is not differentiable because, and I guess you would say something like the left-hand slope. What is the left-hand slope?
6.
6 is, parentheses, is not equal to the right-hand slope, which is 5.
That's it.
Yep, that's what you need to say. Question?
For the continuous, do we have to show that they're equal to 9, or can we just write that they're like?
Yeah, you can just write it there.
Okay.
Or if you wanted to, you could go, well, the limit is 9. Oh, that's because if you plug in 3 here, the left hand and the right hand limit are the same. I think it's just easier to do this, yeah.
Is finding the limit of that just plugging in like that?
But they've gotta be the same, right? Because the left hand limit and the right hand limit gotta be the same. So
Or-
that means you have to plug in 3 into both of these.
Or for continuous, like just finding the limit is just plugging it in for the.
Okay, but
like,
this is the,
finding-
this whole thing here is the definition of being continuous. So you have to show that the limit, which is 9, is equal to the function value at 3. So what is f of 3? Do I plug 3 into this one or this one?
Both.
This, no, this one, or equal to 3. You plug it into this one, you get 9. But it really doesn't matter because if you plug it into this one, you get 9 also, right?
So finding the limit is just plugging it in for.
Into both of them.
Yeah.
Because if you plug it into this one, that's the left hand limit. If you plug it into that one, that's the right hand limit, and they both have to be the same. Because if this one came out to 9 and this one came out to 10, then it's not continuous because the left hand limit and the right hand limit are not the same.
You know how it asks, is it differentiable?
Mhm.
If the thing is not continuous, can we just put no because it's not continuous?
Yep, that's exactly right. But this one was continuous, so. Okay, oh my goodness, we only got 2 more minutes. Okay, you guys remember how to find maximums and minimums and points of inflection?
Zero.
You make number lines. Okay, so like for example, if the derivative is, okay, like the problem I'm giving you there, what about x minus 1 times x minus 2 squared? At what values of x is there an absolute max or an absolute min? I mean, not absolute, relative. So you make a number line, see it's all factored, what goes on the number line? 1 and 2. Plus, plus, minus. How come it stays the same over here? Because you got an even power. Or if you're on the AP exam and you don't know, plug in a number, like 3, plug it in. 1.5, plug it in. 0, plug it in. Okay, so what does this mean? Decreasing, increasing, and increasing. So at x equal 1, is that a max, min, or neither? At x equal 1, look at the picture. It's a minimum, so we have a minimum at x equal 1 because, remember what you need to say? F prime changes from negative to positive. Okay, what about at 2? Is that a max, a min, or neither? Neither. So you got neither at x equal 2 because f prime does not change signs. See, this is all the justification that we gotta get down, but we're gonna be doing drills. Okay, there's only less than a minute left, so you're just gonna have to try your best on number 8. You know what, do you guys remember how to do implicit differentiation? Let's just do something like this then.
Oh, that thingy.
Okay, anytime you have a mixtures of x's and y's, to take the derivative, you gotta do implicit differentiation. So what you do is you just take the derivative term by term across the board. What's the derivative of this? 3x squared. Now, remember, when you take the derivative of x, you get 1. When you take the derivative of y, you get dy dx. That's how you do implicit differentiation. So over here, you gotta use the product rule. Derivative of the first, leave the second one alone. Leave the first